Chapter 2 then of Book 2 of the challenge questions. This is the functions chapter. So to draw a mod function, we're just going to draw the regular function, x squared plus 9x plus 8 in this case. And of course factorize to this, and then roots are at -1 and -8, which means it looks a bit like this. It's a normal project like that. Except when you mod the entire function, what's going to happen is the parts underneath the x-axis are going to flip up above to make this. And then this is of course just a line with y-intercept of 1. This y-intercept is 8, so it's much lower than that, and it looks like this. And now we can use this sketch to find solutions to this. So essentially for these two solutions here and here, like this section of the graph, the original quadratic graph, and this section have been unaffected by the mod, right? Because we drew it like this, and this branch were unaffected by this. And so this branch and this branch are just the equation x squared plus 9x plus 8. So to find those two intersections, we're just going to set this thing here without the mod equal to that thing there, and solve, and you actually get this. And then for these two solutions here, now these two bits here, this curve was flipped over to get it up here. So this entire thing was times by -1 in order to get it from down below to up above. So times all of this by -1 and then set it's equal to that. And then you solve that and you end up with your two solutions there. And you have 4 solutions in total and we're good to go. This next one then, so here's the same kind of question. So this bit here is defined to just be the mod function not doing anything. So this is just 2 into x minus 4 minus 8. And this one here is when this whole thing is times by -1 to get this. Now, to find these two intersections, we just need to set this equal to x minus 9 first. You get this, and therefore this has x coordinate 7. Put it back into here to find y coordinate -2. And then this one over here is going to be this equaling to that, which we can solve to get this. Put it back into here, you get this as your coordinate. And then this bit down here is where the mod changes behavior. So that's when the mod is 0. So x is 4 in that case, and then this whole thing is 0, so you get 4 and then -8. And now we just need to find the area of this scalene triangle. They've asked us to do this loads of times in challenge questions before. Previously, I've just drawn a big box around it and taken away the triangles around it, and then just left me with this bit here. But this time I thought I'd do something different. Just do a bit of Pythagoras to work out all of these lengths. So for example, this length is 1 squared plus 2 squared, square rooted, because it's the difference between the x and the y's. You get this, and like this one here is 4 squared plus 4 squared square rooted, which is this, and likewise here. Now do a bit of cosine rule to find this angle here. So it's going to be this thing squared equals this thing squared plus this thing squared minus 2 lots of this times this cos theta. You eventually end up with cos theta as that. You can use sine squared plus cos squared equals 1 here. Cos squared is 1 over 10, clearly. Take that away from 1 is 9 over 10. Root it is 3 over root 10. And then, of course, if that's sine of this angle here, we can just do a half AB sine C with this is A and this is B, and sine C being this, and we'll get our answer of 6, and that'll be the question done. This question here then, so again, this length here is just where the mod doesn't do anything. So this is 2 into x minus 3 plus 2. This bit here, the mod is going to times all of this by -1. And then likewise, this bit here, the mod's not doing anything, so we're just going to have it as this. And this thing here, the mod is going to times it by -1, and we'll end up with this. Let's find this intersection by doing this equal to that. We can solve that. I'm not going to take any great amount of time doing that. We get this. Put in that x coordinate back maybe into this here, and you find a y coordinate. And now I'm going to be quite lazy about this and do it this in probably the fastest way. This coordinate and this coordinate is where the mods change behavior, which is clearly x equals 3. And this one up here is going to be 3, 10, because that makes this 0. And this here going to be 3, 2. So let's put that down. But of course, that makes this length here 8, because it goes from 3 to 10, and it's just vertical. This length across here is 17 over 3 minus 3, because this distance is 3. This is 17 over 3, so it's just this minus this to get this, which I believe is 8 over 3. And so the area of this triangle is a half times 8 over 3. But these two triangles are symmetrical, right? Pretty clearly. So therefore, we just need to double the answer, and we'll end up with the thing that we've got at the end there. Good. Next one then, on a single diagram, sketch this and this. So this is just an upside down parabola with y-intercept of a squared and roots at a and minus a. All good. This is just a line. Now, y equals x modded is just a v shape like this. This has been shifted a units to the left, so it's just over here somewhere, like this. Write the coordinates of the points where the graph cuts the coordinate axis, so that's going to be -a0, a0, and 0a squared, so that's fine. Given they intersect at x equals 4, so apparently this coordinate has x equals 4, because it can't be over here, because that's a negative. So this is where x equals 4. So what we're going to do is we're going to set this part of the line, which is just where the mod doesn't do anything, which is x plus a. We're going to set that equal to the quadratic, which is a squared minus x squared. And apparently, if x equals 4, this equation is satisfied. So we're just going to put x is 4 in, and we'll do some solving. You'll get a is 5 is the other solution. A is minus 4 is also 1, except a is bigger than 1, so a is 5 is the correct solution, and that'll be done. Good, that's that chapter done.